Hello everyone. Welcome to the lecture series of mole concept. This is a video number 4 for mole concept. In the first video, we have covered the sums based on Gay Lussac's law. In the second and third, both the videos, we have covered the sums based on 𝐒𝐴𝐵𝐷𝗎𝑚's law. Today, we will cover the sums based on percentage composition. My name is 𝐴𝑟𝑝𝑖𝑡𝑎 Banerjee and you are watching 𝐴𝑟𝑝𝑖𝑡𝑎 classes. Let's get started. So, if we have to find out percentage of a particular element in a compound, what is to be done? So basically this is the first question which I have taken a very basic question in the first one. It's calculate the percentage by weight of carbon in carbon dioxide. So the compound is carbon dioxide and you have to find out the percentage of carbon. So what is the formula? Let us first find out. The percentage of any element is equal to weight of that element in the compound divided by total molecular weight of the compound into 100%. This is the formula to find out the percentage composition. Now, what does it mean? Let us see this. Let us solve the first question. They are asking what is the percentage of carbon in carbon dioxide. So first of all, you have to find out the molecular weight of carbon dioxide. So let us find molecular weight of carbon dioxide. I hope everyone knows how to find out the molecular weight. It is the algebraic sum of all the atomic weights of all the elements present in the molecule. So it is atomic weight of carbon plus 2 into atomic weight of oxygen. I am writing it. This is the first sum, so I am writing it. Basically, you do not have to write it. You can directly do this. Atomic weight of carbon is 12 plus 2 into, there are 2 atoms, so we are taking 2 into, atomic weight of oxygen is 16. So molecular weight of carbon dioxide is coming 44 gram. So this is the molecular weight of carbon dioxide. Now here, percentage of carbon would be weight of carbon, which is 12. 12 gram is the weight of carbon in this compound. So weight of carbon will take in the numerator divided by the total weight of the compound. That's the molecular weight of the compound, which is 44 here, into 100%. Now we need to calculate this. Let us solve this. 4, 3, 4, 11. So it's coming 300 upon 11%. So you can do this like 300 divided by 11. 11 2 is 22. 8 0. 11 7 is 77. 3. So we can write 27 whole 3 upon 11%. So this is the percentage of carbon in carbon dioxide. So the basic formula is, if you have to find out any element's percentage in a compound, first you have to find out the molecular weight of the compound. Then we have to take the element's weight in the numerator divided by the compound's molecular weight into 100%. That's it. Okay. Let us see the next sum. Question number 2. So the question number 2 is, find out the percentage by weight of sodium in Na2CO3. So the compound is here Na2CO3, sodium carbonate. First of all, we will find out the molecular weight of sodium carbonate, Na2CO3. You can write down this way because capital M denotes the molecular weight of Na2CO3. So that is equal to 2 into atomic weight of sodium, which is 23. So you can clearly see there are 2 atoms. So we have taken 2 into atomic weight of sodium plus atomic weight of carbon, which is 12. Plus atomic weight of oxygen into 3, because there are 3 atoms of oxygen. So it is 3 into 16. So it comes 46 plus 12 plus 48, which is 46 plus 48 plus 12. 106. So it is 106 gram. So the molecular weight of Na2CO3 or sodium carbonate is 106 gram. Here I have to find out the percentage of sodium. So I'll write percentage of sodium is equal to, I'll have to take weight of sodium in the numerator, which is 46. So 46 upon 106 into 100%. So now we will calculate this. 46 and 106, they go by 2's table. 2, 2, 2, 3, 2, 5, 2, 3. So it is 2300 divided by 53%. We can calculate this here. 2300 upon 53. So it's 43 whole 21 upon 53. So we'll write 43 whole 21 upon 53%. You can keep this in mixed fraction or you can keep it in points as you wish. Okay. So that was the second sum. Let us start with the third sum. We have to find out the percentage by weight of aluminium in aluminium nitride. So the compound here is aluminium nitride. We'll find out the molecular weight of aluminium nitride. So it's atomic weight of aluminium plus atomic weight of nitrogen. Atomic weight of aluminium is 27. Atomic weight of nitrogen is 14. So it comes 41 gram. So this is the atomic weight of aluminium nitride. Now percentage of aluminium is weight of aluminium in the numerator divided by 41 into 100%. So when you calculate this, it's coming 2700 upon 41%. So when you calculate this, you get the answer. You can get the answer in mixed fraction or in points as you wish. Let us go for the second sum now. So let us proceed to the next question, that is question number 2, which says, calculate the percentage of iron in K3FeCN6. You can see this is a compound. This type of compounds are called as coordination compounds, which we are going to study in our higher standards. So this is K3FeCN6. Here we have to find out the percentage of iron. Also they have been given the atomic weights. Potassium is 39, Fe is 56, carbon is 12 and nitrogen is 14. So let us start with this. The compound is K3FeCN6. So we'll find out the molecular weight of K3FeCN6. So this will be is equal to 3 into atomic weight of potassium. I am writing it this way, 3 into atomic weight of potassium plus FeCN6. So atomic weight of Fe, so I am writing it this way in bracket plus. Now CN6, that means 6 into atomic weight of carbon and atomic weight of nitrogen. So I will write it this way, 6 into atomic weight of carbon plus atomic weight of nitrogen. Okay. So 3 into your potassium is 39 plus iron is 56 plus 6 into 12 plus 14. So this is 117 plus 56 plus 6 into 26. It comes 117 plus 56 plus 156. Let us calculate this, how much it is coming. We will add all these three, 156 and 56. $329. So it's coming 329 gram. So that is the molecular weight of this compound. Now we need to find out the percentage of iron. That is equal to weight of iron should be in the numerator, which is 56 upon 329. That's the molecular weight of the entire compound into 100%. So if you calculate this, it comes around. We'll do the calculation. You can do it on your own. I'll just check the calculation is coming around 7.03%. So it is coming 7.03%. You can calculate, you can keep your answer in decimals or you can keep your answer in mixed fraction. Let us proceed to the question number 3, which says that calculate which of the following, calcium nitrate or ammonium sulfate, has a higher percentage of nitrogen. So you have two compounds here, calcium nitrate and ammonium sulfate. You have to find out which contains higher percentage of nitrogen. That means you have to find out the nitrogen percentage in calcium nitrate, also nitrogen percentage in ammonium sulfate, and you have to see which contains more percentage of nitrogen. So let us do. For this question we need to know the formula also. Calcium nitrate, what's the formula? CaNO3 whole twice. This is the formula for calcium nitrate. If you do not know the formula, you will not be able to do the sum, right? So calcium nitrate, molecular weight of calcium nitrate we'll find out. So it is atomic weight of calcium plus 2 into atomic weight of nitrate. So 2 into atomic weight of nitrate. Now again we have to split this. It's atomic weight of calcium plus 2 into atomic weight of nitrogen plus 3 into atomic weight of oxygen. Now we can put the atomic weights. For calcium it is 40 plus 2 into nitrogen is 14 plus 3 into 16. Mostly the atomic weights will be given to you, and if it is not given, for the common elements we should remember the atomic weights. 40 plus 2 into 14 plus 48. So it comes 40 plus 2 into 62. 40 plus 124. So that's 164 gram. So this is the molecular weight of calcium nitrate. Now the other compound is ammonium sulfate, which is NH4 whole twice SO4. We need to find out the molecular weight of ammonium sulfate. So that is equal to 2 into NH4 plus sulfur plus 4 into oxygen. Now we have to split this up. 2 into nitrogen plus 4 hydrogen. We'll put another bracket plus sulfur plus 4 into oxygen. So I am writing this so that you do not have any confusion. If you can do it in one line, you can do it in one line, no problem. So this is equal to 2 into atomic weight of nitrogen is 14. This is 4 into 1 plus 32 plus 4 into 16. So it's come 2 into 14 plus 4, that's 18. So 2 into 18 plus 32 plus 64. So that's 36 plus 32 plus 64, which is coming 132 gram. So we got the molecular weight of both the compounds. Now I'll erase this part so that we can do the further part. So this is coming 164, I'll write it here. Molecular weight of calcium nitrate has come 164 gram, and here molecular weight of ammonium sulfate has come 132 gram. Now we have to find out the percentage of nitrogen in both the compounds, right? So here percentage of nitrogen. Now see how much nitrogen is there. Nitrogen is 2, N2, that is 14 into 2, that is 28 gram of nitrogen is here out of 164 into 100%. So when you calculate this, let us first reduce it into the lowest term. This 425 and this is 441. So it's 28 into 25 upon 41. If we do little, approximation, if we take it as 40, then it will be 5558 and 4247. So it's coming 35 upon 2, which is 17.5%. Yes, so it's coming 17.5%. I have done little approximation here. In place of 41, I have taken 40. So it's coming 17.5. Since I have taken 40, so in place of 41, this will be little lesser than 17.5, but it's fine. We can compare at least. Let us see what is it coming from here. Percentage of nitrogen. Now here also nitrogen is 2. So that is 28 upon 132 into 100%. So this comes 25. So it is 28 into 25 upon 33. If you do this calculation, it will be coming around 21.2%. So it is coming 17.5%, here it is coming 21.2%. That means nitrogen percentage is more in ammonium sulfate. So the last line we should write, ammonium sulfate contains higher percentage of nitrogen. Ammonium sulfate contains higher percentage of nitrogen. So let's start with the next question. Question number 5. State which of the following are better fertilizers, potassium phosphate or potassium nitrate? That is your first question. So to decide which one is a better fertilizers, we have to see the percentage of NPK. N for nitrogen, P for phosphorus and K for potassium. So we have to see which fertilizer contains more percentage of either of these three elements. So that fertilizer will be considered to be the better fertilizer. Now in potassium phosphate, let us write down the formula. Potassium phosphate is K3PO4. This is potassium phosphate, and potassium nitrate is KNO3. Now in both the fertilizer you can see K is common. So we have to find out the percentage of potassium in both fertilizers. Whichever contains more amount of potassium or more percentage of potassium, that is a better fertilizer. So let us find out the percentage of potassium in potassium phosphate. Molecular weight of potassium phosphate first, that is 3K plus P plus 4 oxygen. Potassium's atomic weight is 39. Phosphorus atomic weight is 31 plus oxygen is 16. Mostly this will be given to you. So this is coming 117 plus 31 plus 64. 212 gram. This is the molecular weight of potassium phosphate. Now molecular weight of potassium nitrate, that is atomic weight of potassium plus atomic weight of nitrogen plus 3 into atomic weight of oxygen. This is 39 plus 14 plus 3 into atomic weight of oxygen is 16. So it's 39 plus 14 plus 98, sorry. No, sorry, 48. 16 to 3 is 48, sorry. So 39 plus 14 plus 48. 101 gram. So we got the molecular weights of potassium phosphate and potassium nitrate. Now we need to see the percentage of potassium and in both the compounds. Let me just take the calculations once. Here it is 212 and here it is 101 gram. Yes, now we'll find out the percentage of potassium. So I'll write it here so that I'll rub this part so that I can continue with the rest of the portion. So we'll find out percentage of potassium in K3PO4. So that is weight of potassium, which will be 3 into 39 in the numerator divided by 212 into 100%. So this is coming 117 upon 212 into 100%. If you do this calculation, we can do the calculation. I have done it here. It is coming 55.2%. So this is 55.2%. Same thing we'll do here. We'll find out the potassium percentage of potassium in KNO3. So here we can see potassium is only 39 gram here. 39 upon the molecular weight of this is 101 into 100%. So if I do little approximation, if I take it as 100, so it is 39 upon 100 into 100%, which gets cancelled, it comes up to 39%. So this is 55.2% and this is only 39%. So the better fertilizer is K3PO4. So we can write down that K3PO4 is the better fertilizer. In the similar way, if you have to find out which one is better fertilizer, urea or ammonium phosphate. Now just look at it. Urea, the formula for urea is NH2CONH2. This is the formula for urea. And formula for ammonium phosphate is NH4 whole thrice PO4. Now in both the fertilizer we can see nitrogen is common. So we have to find out the percentage of nitrogen in both the fertilizers and we have to see which one is a better fertilizer. Let us do this. Molecular weight of urea first we'll find out. So this is atomic weight of nitrogen plus 2 into atomic weight of hydrogen plus atomic weight of carbon plus atomic weight of oxygen plus atomic weight of nitrogen plus 2 into atomic weight of hydrogen. Okay, so let us first find out this. 14 plus 2 into 1 plus 12 plus 16 plus 14 plus 2 into 1. It comes 14 plus 2 plus 12 plus 16 plus 14 plus 2. So it is 14 plus 14, 28, 2 plus 2, 30, 30 plus 16 is 46, 46 plus 12, 46 plus 12 is 58 it is coming. 14 plus 14, 28, 29, 30, 32, 32 plus, okay, so it is coming 60 gram. So molecular weight of urea is 60 gram. I am writing it here. You can do the calculation. This is simple addition. You can, all of us can do this. Okay, now here we'll find out the molecular weight of ammonium phosphate. That is NH4 whole thrice PO4. So that will be 3 into NH4 plus phosphorus plus 4 into oxygen. Now again split this NH4. 3 into nitrogen plus 4 into hydrogen, another bracket I'll put, plus phosphorus plus 4 into oxygen. Now 3, nitrogen is 14 plus 4 into 1 plus phosphorus is 31 plus 4 into 16. So it comes 3 into 18, this is 14 plus 4 is 18 plus 31 plus 64. So it is 54 plus 31 plus 64. If I do the calculation, 54 plus 31 plus 64, 149. So it's coming 149 gram. Let me just check the calculation once. I have done it here. So, yes, it is 149 gram. Now, so this is 149 gram, I'll write it here. Now let us find out the percentage in both the compounds to see whether which one is a better fertilizer. Percentage of nitrogen. Here nitrogen is 14 plus 14, 28. So I'll write 28 in the numerator upon 60 into 100%. 0 and 0 cancels. 2, 3, 2, 14. So it's 140 upon 3. You can do the calculation, 140 upon 3, which will be 46.67%. 46.67%. And here we will find out percentage of nitrogen. Here we can see nitrogen is 3. The atoms of nitrogen is 3. So 3 into 14. So that's 42 upon 149 into 100%. Now if you do this calculation, it is coming 28.19%. So here it is 46.67% and here it is 28.19%. So the better fertilizer is urea. Let us start with the next question. Question number 6. Calculate the percentage of carbon in a 55% pure sample of calcium carbonate. So we have a calcium carbonate whose purity is 55% and we have to find out the percentage of carbon. So first of all, the compound is calcium carbonate. Find out the molecular weight of calcium carbonate. So that's Ca plus C plus 3 into oxygen. Ca is 40 plus 12 plus 3 into 16. So that's 40 plus 12 plus 48. So that is 100 grams. So this is the molecular weight of calcium carbonate. That means 100 gram of calcium carbonate contains 12 gram of carbon. Now the compound is only 55% purity. That means 100 gram of the sample contains only 55 gram of the pure calcium carbonate. So in 55 gram of pure calcium carbonate, how much carbon is there? We can see in 100 gram carbon is 12. So in 55 gram of the sample, carbon is how much? We have to take 55 by, because the calcium carbonate is only 55% pure. That means 100 gram of the sample contains 55%, 55 gram of pure calcium carbonate. Okay. So percentage of carbon in 55% pure calcium carbonate is equal to 12 upon 55 into 100. I have done this calculation over here. It's coming 6.6 So this is the percentage of carbon in 55% pure sample of calcium carbonate. Question number 7 in front of you. Calculate the percentage of water of crystallization in hydrated copper sulfate. They have also given the formula for hydrated copper sulfate. We already know copper sulfate contains 5 molecules of water of crystallization, which is also called as copper sulfate pentahydrate, or this is hydrated copper sulfate. They have been given the atomic weights of all the elements. We have to find out the percentage of water of crystallization. So first of all, we will find out the molecular weight of hydrated copper sulfate. So that is here copper plus sulfur plus 4 into oxygen plus this 5 molecules of water will get added to this 5 molecules of water. Now water is 2 of hydrogen plus oxygen. I will put another bracket over here. Now copper is 63.5, sulfur is 32 plus 4 into oxygen is 16 plus 5 into, now molecular weight of water is 18, that we must know, but if you do not know, we can do it here. 2 into 1 plus oxygen is 16. So finally it will come 2 plus 16, that is 18. So 63.5 plus 32 plus 4 into 16 is 64 plus 5 into 18. 63.5 plus 32 plus 64 plus 5 into 18 is 90. So if you calculate this, it will come 249.5 grams. 249.5 grams. This is the molecular weight of copper sulfate. Now they are asking for percentage of water of crystallization. So we can see water of crystallization is 90 out of 249.5 grams. So percentage of water of crystallization is equal to, in the numerator we will take 90 upon 249.5, that's the entire molecule's molecular weight, into 100%. So if you calculate this, I have run the calculation, it is coming 36.07. So 36.07 is the percentage of water of crystallization in copper sulfate pentahydrate. We have reached to question number 8, and this will be the last question for today's topic. The question says hydrated calcium sulfate, which is CaSO4.XH2O, contains 21% of water of crystallization. Calculate the number of molecules of water of crystallization, that is X in the compound. So very clearly you have been given a compound CaSO4.XH2O, where 21% is the percentage of water of crystallization. So this is 21%. So obviously this much will be the percentage of CaSO4, only CaSO4 will be 100 minus 21, that is 79%. So in this hydrated molecule, 79% of calcium sulfate is there and 21% of water of crystallization is there. We need to find out what is the number of molecules of water of crystallization, whether it is 1, 2, 3, 4, that we need to find out. So first let us find out the molecular weight of CaSO4, which is atomic weight of Ca plus atomic weight of sulfur plus 4 into atomic weight of oxygen. So this is 40 plus 32 plus 4 into 16, and if you calculate, this will come 136 gram. Okay, so that means if the entire molecule is CaSO4.XH2O, if you consider this as A, in this 136 gram is only CaSO4. Okay, so, and which is your 79%. So I'll write 79% of the entire molecule A is equal to 136 gram. Therefore, 79 upon 100 into A is 136 gram. Therefore, A is 136 into 100 upon 79 gram. So the value of the entire compound's weight is 136 into 100 upon 79. So this is 136 into 100 upon 79. So the rest of the amount, that is 21%, is water of crystallization. So I'll write it here. 21% of A is equal to the water of crystallization. Just a minute, I'll just see the calculation. So 21% of A is the water of crystallization, that is X molecules of water. X molecules of water weighs how much? 21% of the entire molecule is X molecules of water. So 21 upon 100 into A. A is how much? 136 into 100 upon 79 is equal to X molecules of water of crystallization. Water of crystallization. Write down the whole thing, water of crystallization. So this is coming 100 cancels. So X molecules of water of crystallization is equal to, we get 21 into 136 divided by 79. Now if you remember, we have a formula, number of molecules is equal to number of moles into molecular weight. Number of molecule is denoted by N. Capital N is equal to small n into molecular weight. So in this case, in place of X is the number of molecules, we can substitute it by number of moles into molecular weight of water, and that is equal to 29 into 136 upon 79. Now molecular weight of water is 18. So N into 18 is 21 into 136 upon 79. I'll do the rest of the calculation here. Therefore, N is equal to 21 into 136 divided by 79 into 18. And if you calculate this, it will come almost equal to 2. Therefore, X, the value of X is coming 2. Therefore, the hydrated molecule is CaSO4.2H2O. So here we have completed the questions based on percentage composition. In the next video, I'll come up with the questions based on empirical formula and molecular formula. So stay tuned and thank you so much.